Hello, I'm DJ Rao. This is the last part in the five-part series designed to provide a rapid introduction to concepts in C++ so that programmers can quickly ramp up on developing programs in C++. Ensure you view the other four parts of this series that cover the key concepts required for developing comprehensive programs in C++. This part of the series provides a basic introduction to object-oriented programming in C++. Keep in mind this presentation and this series is not meant to be a primer to object-oriented programming. Instead, it merely provides a rapid overview from a C++ perspective. So if you're new to object-oriented programming, then you need to start with a more introductory tutorial before referring to this series of presentations. Before you create classes and start developing your own classes in C++, first consider using existing standard containers like std_pair and std_tuple because oftentimes these standard classes meet a lot of the usual encapsulation requirements that you might come across in programs. C++ is a strongly object-oriented programming language, so it supports the four fundamental tenets of object-oriented programming, namely encapsulation, abstraction, inheritance, and polymorphism, and you should be comfortable with these concepts before proceeding further with this part of the presentation. Let's look at the philosophy in C++. As a general rule of thumb, a class should behave just like a standard class, say for example like the std_string class that we've been using. That means a class that you design should provide convenient ways to create objects. That means you should think about what types of constructors that you would like to support in your class. It should provide appropriate methods to support various functionalities, so you need to have getters, setters, and other methods that provide certain types of functionality. You should consider providing appropriate comparison operators so that it enables natural use of your classes, and we'll briefly look at some operator overloading examples in this part of the presentation. Of course, you should think about how to read and write your object by streamlining input-output by overloading stream insertion and stream extraction operators, and then we'll look at some examples of that. And of course, you should also think about how to implement a simple destructor so that you can clean up any resources when the object is no longer used. Keep in mind, not all of the above functionality is needed in every class, and the compiler often generates some of the default methods for these, so always prefer to use the defaults that the compiler provides. But if you want to have a more comprehensive class, you would have to implement all of these 5 features. And of course, keep in mind, designing a good API in any of these classes is a complicated topic, and this presentation is not meant to discuss API design and such, but just introduce these concepts from a C++ perspective. All right, let's start with a simple C++ class. So in C++, you would start with the keyword class, and you would give the name of a class. And notice the open curly and close curly brackets with a semicolon at the end. Don't forget the semicolon at the end of the class definition. In this class, we're going to have 2 simple instance variables. Both of them are strings, word1 and word2. And this is the simplest class. And when you define a class like this, the compiler automatically provides default constructors, destructors, basic comparison operators, and such. But it will not provide a stream insertion or stream extraction operator. Now that we've defined a class, we can use it as if it's any other data type. So you could use it to define vectors that contain pairs of words. So you can use this word pair anywhere you would use an int or a std_string, so it would behave similarly. So for example, you can write methods, so you can return word pair from a method. So here's an example where you're creating an object called WP, which is of type word pair. Notice that we're not using any new operators. You want to define an object, specify you want an object, and you can start working with it like a normal integer data type. Now let's look at some more advanced concepts with object-oriented programming in C++. So let's continue with our word pair example, except this time we are going to make word1 and word2 be private, so this gives better encapsulation. And now that these are private, You will not be able to directly access these instance variables like we did in the previous example. So instead, you would have to provide some kind of a constructor that initializes the words. Oftentimes, you may provide multiple constructors to initialize the instance variables. Here we have two different constructors. And keep in mind, it's always a good idea to have a no argument constructor so that it's convenient to use your classes with standard containers like vector and unordered map. Typically, you will have a destructor for every class. It is the converse of a constructor. Constructor constructs an object. Destructor is meant to clean up all of the resources associated with an object. Typically, your destructor may not have any work to do, so you would implement a empty destructor. And notice the tilde at the beginning of the method name. So constructors have the same name as the class name. Destructors have the same name but with a tilde in front of it. Of course, you would have some getter methods and setter methods. Here's an example of a getter method. Typically, all of your getter methods should be defined as constant methods. Constant methods cannot modify instance variables, or they're not meant to modify instance variables. So such constant methods can be called on all objects, including constant objects. So if the user wanted to create a constant word pair, the user will be able to create a constant word pair and then use this constant get method to access information in that constant object. Classes can be placed in any source file in C++. There is no naming requirements on which class should be placed in which file. So file names and class names do not need to match, and a single file can contain multiple classes. So this is an important concept to keep in mind in C++. However, the general programming convention in C++ is to use separate files for separate classes. Typically, as a rule of thumb, we will keep file names and class names to match. This is only a convention and not a language requirement. In C++, we'll use a split design. We will have what are called header files that will contain just the prototypes and maybe implementation for short one-liner methods. Most of the implementation will be done in source files, which will have the .cpp extension for them. Let's look at this through an example. So here's a person class. Notice that the name of this file is going to be person.h, but keep in mind that the file names and class names do not need to match in C++, but we are going to do that as a convention. And then this class has a constructor. Notice that we are setting some default argument values for a constructor. So since it has default values, this constructor can also act as a default constructor that does not require any arguments to be supplied. And of course, we have a couple of getter methods just for example. Note that this class does not have any setter method, so currently it's immutable. That means once the object is created, you will not be able to modify it. The header file typically has only declarations. So keep in mind the API in the header is like a contract. In the header, you only promise to implement a class with certain sets of methods and instance variables, but we have not yet implemented some of these methods. So we need to implement these methods in the source file or the CPP file. If we forget to implement these methods when you compile and try to run your program, you'll get a compiler or a linker error that says some of these methods are undefined. Notice that it says undefined reference to some of these constructors and destructors. And this is the compiler and linkers lingo to let you know that you forgot to implement some of the methods. All right, let's look at the implementation for these. Notice that now there's going to be in a file called separate file called person.cpp. And in addition, you will have to scope each one of these methods with the name of the class. Keep in mind, you can implement multiple classes in a file. So in C++, you have to scope the names of these methods with the name of the class followed by a colon. So notice how the constructor is implemented. It says person : That means you're saying you're going to define a method for the person class, and then the name of the method is person that takes 2 arguments. Notice that when you implement these methods, you do not specify the default arguments as such. Those are already done in the header. Here you only implement the body. And of course, these methods are pretty simple and straightforward. And of course, here notice how these instance variables are being initialized in the constructor. So prefer this type of initialization over assignment. And of course, you need to implement all of the methods even if the body is empty. Keep that in mind. And of course, method signatures must be the same as in header, so you have to put the same const and return data types and such for each one of these methods. Before we move forward, let's understand the use of constructor and destructors as to when they are called. Constructors are called when objects are created, and of course, the constructor that's being called will depend on the type of constructor you're using and depending on how many parameters you're passing to it. And the destructors are automatically called when objects go out of scope. Let's understand this through an example. Here there are three objects, P1, P2, and P3, and let's understand the lifetime of these objects. First, when the main method is run, the constructor for P1 is called. It calls the two parameter constructor there. Then when the code goes into the if statement, it calls the default constructor for P1, for P2 and P3. Here it calls the default constructor because there are no arguments specified for it. Now, the scope of the objects P2 and P3 are within the body of the if statement. So the moment the if statement is done, the destructors for P2 and P3 are called. Keep in mind, it'll call them two separate calls to the destructor. Typically, you'll get the first call will be for P2 and the second call, destructor call, will be for P3. Now, the main method continues, and when the main method is done, the scope of P1 object ends, and the compiler will automatically call the destructor for P1 when it reaches the close curly bracket for the main method. So it is important to have a mental model on the scope of these objects and corresponding lifetime of the objects and when the destructors are called. C++ also defines an automatic variable called this. This is available and defined in all non-static methods in a class, and this happens to be the same data type of the class in which it is being used. So obviously, if you have different classes, the data type of this variable will be different in those different classes. Keep in mind, in C++, this is a pointer, so you will use the arrow operator to access instance variables. So here's an example where you're returning, assigning some value and checking some value, and notice how this pointer is used in that example. All right, now that we have some basics done, let's look at operator overloading. Remember that when you develop many classes, they can have many methods, and remembering all of the methods in each one of these classes is not tractable from an API perspective. So instead, in C++, the language prefers to use standard operators and reuse those standard operators for performing operations. And this process of reusing standard operators is called operator overloading and is used to streamline APIs, and it enables us to use standard operators even with custom or user-defined classes. Keep in mind, operators are just regular methods, and obviously they adhere to all of the conventions on method calls and parameter passing that we reviewed in the second part of this series. The only difference is operators, the method name looks a little different. Just because you're not used to looking at method names like this, it feels a little different. And of course, they have a slightly different way of calling the methods as well. The syntax is different, but the method call semantics are the same. Only the syntax is different. Of course, different operators will need different parameters, just like different methods need different number of parameters. So for example, addition, you need two objects that you want to add together, so it'll take two parameters. Unary minus will require only one parameter, so on and so forth. And we'll look at a few key operators in this presentation. All right, let's start with stream insertion. This is for printing the values of operators. So let's say we have a person class that is defined with some methods in it. Typically, you will write something like a print method that we've seen this one before, that takes an abstract output stream and prints the ID and the name of the person. And typically, you will return the output stream to which the data was printed as a convenience. So the only thing we're going to do in operator overloading is basically change the name of that print method to operator less than less than. Remember, less than is the stream insertion operator. And notice that the less than is used consistently in that method. Everywhere you're printing, you'll see the same less than operator. So all we have done is taken the name from the print method and then simply change it to operator less than less than. And that's about it. That's how you overload that operator. It's as simple as writing a method. And of course, we need to define and declare that we are implementing this method in the header file. So we'll put a declaration for it in the header. And of course, we need one extra keyword there, which is the friend clause that basically permits the stream insertion operator access the private instance variables in that class. We could have used getters, but here we want to directly access the private instance variables. So we are defining a friend keyword there. And that's about how to define a stream insertion operator. Now let's look at how to do stream extraction to read information for an object. So assume the same person class is defined. And now we'll typically write a read method, which is going to take an input stream because we want to read data and the object into which we want to read, and it extracts the information from the stream into the object. Now, again, the only thing we're going to do is change the name of the method. Instead of simply calling it read, which we would normally do, we're going to call it operator greater than, or the stream extraction operator. Notice that operator greater than is the name of the method. It's one name, even though there are special characters in there. And of course, just like we did with stream insertion, we need to declare the method in the header file in the class definition. And we use the friend so we can directly modify the private instance variable in that class. Now that we have defined these operators for stream extraction and stream insertion, we can use them just like we normally do with any other data type. So let's say we have two people, a boy and a girl. We can now read data for the boy and a girl. Here the example shows reading from the console input. And so you could use the same approach for files, string streams, or even reading data from sockets. It will be just fine. Of course, here, let's look at the method call here. When we call it, cin will by default will become the input stream, and the object into which the data is going to be read in the first call will be to read data for a boy. In the second call will be to read data for the girl object. So that is how those calls work. Now let's look at how to print. Similar strategy. Normally you would use stream insertion operator to print data. So notice how here we are able to print data for boy and girl. And correspondingly, the compiler will automatically call the stream insertion operator. In this example, it'll be cout for the output stream. And in the first call, the object will be boy. So person P will refer to a boy. The second call, person P will refer to the girl to print the information. So notice how once you implement the stream insertion, stream extraction operators, using them, you follow the same standard input-output paradigm that we have been constantly reviewing throughout this presentation series. Of course, you can also use the stream insertion operator to create string representations by simply inserting the object into a string stream and returning the string representation. So this is a convenient way to implement the toString method for a class. Let's look at another example where we want to work with vectors. This is just a simple example to illustrate how stream reading and writing of vectors can be done. So here, notice that we want to read data into a vector. We are going to read a bunch of numbers. So here we have a standard while loop that keeps reading data and adding information to a vector. And notice the name of the method is operator greater than, and this will work with a list of integers. Conversely, we are printing the list of integers here. So it's the converse of reading. Here we are printing the information. Let's look at another overloading example for comparison. So assume that here we have an element class, just a different example, and it has two instance variables, a name and an atomic number. So here we'll implement an operator less than. Notice the less than is for comparison. You could implement it in different ways. Here it's doing a simple comparison based on atomic weight, and it's returning true or false. Now in the main method, we can define two elements, say carbon and helium, and we can check or compare these two elements naturally by using the less than operator. So here, reading that code, you're asking a question, is E1 less than E2? And it returns a true or false. And this approach streamlines API and makes it very intuitive to use objects and classes for doing logic and other operations. This is somewhat similar to how the string class works as well. We've been using strings using standard comparisons. Now when we implement our own user-defined classes, we can use the standard comparison operators as well. Let's look at another example with the element class. Let's look at an example where we want to implement some kind of subtraction operation. This is just an example. And here we implement the subtraction operator, takes two elements that you want to subtract, and creates a new element as a result of the subtraction. And now in the main method, we can use this operator, define two elements, and we can simply say u1 minus u2, and by default, the compiler knows that element has a subtraction operator and will call that method with e1 referring to u1 and e2 referring to u2, and the result, whatever is returned, is assigned into the fission object in the main method. This is just an example of how you could do operators. Similarly, you can implement addition, subtraction, multiplication, division, modulo. So you can almost overload almost all of the standard mathematical operators in C++ and streamline the API for different classes. All right. That was about all you need with most of the core object-oriented concepts in C++. So let's review the rules of thumb for good C++. So always never use the new operator in C++ that is reserved for library builders. In all of the series, we haven't used new one time in any of the examples. Of course, use the standard stream extraction operator for reading data. We've now seen how operator overloading works, and we know why we are using the stream extraction, because you can consistently use the same pattern for reading data, and it makes life easier to remember one single pattern to read data. Sometimes you may need to read a whole string, a whole line, then use std_getLine, and to handle quotes around words, use std_quoted. Again, for output, always use the stream insertion operator as your default, and we have seen how to implement stream insertion operators for vectors, and you could do that for unordered maps, or you could overload them for your classes and streamline the process of printing information. Always use standard comparison operators. Now that you know how to do operator overloading, you know how these standard operators work. So always use these standard operators because it makes the logic and reading the code so much simpler. Keep the parameter passing convention in mind. It applies to all of the methods and functions consistently in C++. So please go and review some of the parameter passing conventions from part 2 of this presentation to ensure that you have a good understanding of it. As a general rule of thumb, prefer to pass primitives by value and prefer to pass objects by reference, preferably by constant reference. Always prefer to use std_vector instead of arrays. It'll help you along. All right, that brings to the end of this series. Now you have all of the concepts to develop some of the complex programs in C++. Part 1 covered the basics, so the basics are still important. Part 2 might be one of the most important parts, where we cover function calls and parameter passing, and this concept applies throughout all of the presentations, so it's important to review part 2. Part 3, we focus on input-output streams. Make sure you keep input-output simple and straightforward using stream insertion, stream extraction operators. We've looked at some of the containers. The two often used containers are vectors and unordered map. Unordered map is super important to keep in mind, as it'll help you during interview and job interview questions. So make sure you have a good understanding of unordered map. And of course, we have done some of the object-oriented programming concepts, at least the basics, in this part of the presentation. C++ is a powerful and comprehensive language, so one short tutorial will not be able to cover all of the aspects of this language, but this presentation covers almost the key concepts. That means you have a majority of the use cases covered here. And of course, the key thing to build strength in programming is practice, practice, practice. So there is an online website called LeetCode that has a lot of job interview style problems. These are short problems with different skill levels that you can practice. Additional concepts that you would like to cover in your journey to become an expert in C++ is, of course, learn new algorithms and data structures. Definitely review the methods in the algorithms header in C++. That algorithms header has the core searching, sorting, heap, and other data structure algorithms that you should at least know how to use them, even if you do not know how to implement them. Know how to use these standard computer science algorithms, and it'll help you on the long run. Of course, we haven't done much with generic or template programming. That is something that you can learn. And of course, it's important to learn some of the object-oriented design patterns like singleton, abstract factory, bridge. These are all very commonly used object-oriented design patterns, and it's good to know those. And of course, there are several resources on the isocpp.org, which is the international standardization body for C++. They have a lot of resources, and specifically the C++ core guidelines is a good resource to review some of the modern C++ concepts and ideas. Hopefully, you find this series useful and enjoyable. Happy C++ coding!